We'll go ahead and start with these problems. With problem number 1, we got 7 to the 3x minus x squared equals to 7 squared. And we're asked to solve the given equation for x. Here we're going to solve the given equation for x. And in this problem here, you can see that the bases are the same on both sides. So that means I can set this exponent to be equal to that exponent. That means I can set 3x minus x squared to be equal to 2. And notice I do have a quadratic equation, so to solve this quadratic equation, I need to get a 0 on one side. So that means here, this is what I'm going to do. I'm going to move the minus x squared over. That's going to be x squared here. Move the 3x over. I'm going to have a minus 3x, and I have the 2 here, so this will be plus 2. And that's equal to 0. So now, x squared minus 3x plus 2, I can factor that out into two binomials here. So that means the x squared would be x and x. Now I need factors of 2 that will give me negative 3x as a middle term. Negative 2 and a negative 1. So I get x minus 2 times x minus 1 equal to 0. Now I can set each binomial factor equal to 0. So that means x minus 2 is equal to 0. X minus 1 is equal to 0. So for x minus 2 equals 0, that means x will have to be equal to 2. And for the x minus 1 equals 0, x equals 1. So these are my two solutions for this exponential equation. X is equal to 2 and x is equal to 1. Okay. Are there any questions about problem number 1? All right, number 2. A person wishes to have $15,500 cash for a new car 7 years from now. How much should be placed in the account now if the account pays 4.7% annual interest rate compounded weekly? Okay, so let's take a look at what we have here. He wants to have $15,500 cash. That would be what A is. Our P is going to be our present value, which is what we're trying to find. Because we're trying to find out how much he needs to put in there now. And our interest rate, 4.7%. What's 4.7% as a decimal? 0.047. And of course the time, and of course it's compounded weekly. Our time is 7 years. That's given to us as well, so we might as well include that. Now, if it's compounded weekly, let's think about this. How many weeks are there in a year? 52 weeks. And in this case, we have to use this formula. A is equal to P times the quantity 1 plus R divided by N raised to the N times T. That's when you have N number of compoundings. We must use this formula. And our amount is $15,500, so we'll replace the A with 15,500. That's equal to P times 1 plus the R, that's going to be 0.047, divided by N, which is 52, times, and that's going to be raised to the N times T. N, of course, is 52, and T is 7. And what I'm going to do here is just multiply 52 times 7. I'm just going to rewrite all of this in parentheses. 52 times 7 ends up being 364. So this exponent for the 52 times 7 is 364. And here's what I'm going to do. I'm going to get p by itself. It's multiplied by this expression here, so I can go ahead and divide both sides by that 1 plus 0.047 divided by 52, and that quantity is to the 364th power. So that means P is equal to, and all of this can be put in the calculator like this. Let's see, 15,500. That'd be divided by, now the denominator needs to be in parentheses, so be left parentheses, 1 plus 0.047 divided by 52, close parentheses, and then that's going to be raised to the 364, so it'd be the hat key, then 364, then press enter. And in this problem, they say round to the nearest dollar. So what would this amount be to the nearest whole number?
11,156.
Yeah. $11,156. So pretty much to answer that question, this person must put $11,156 in the account right now if that account does pay 4.7% annual interest rate and is compounded weekly. Okay, that's how we would do number 2. Okay, questions on that? Okay, problem number 3 is a logarithmic equation. Here we got log to the base 10 of the quantity x plus 4 minus log to the base 10 of the quantity x minus 4 is equal to 1. So here we want to find out what x is. Log to the base 10 of the quantity x plus 4 minus log to the base 10 of x minus 4 is equal to 1. So now if you notice, we have a minus sign in between the logarithms. So that means we have the difference of the individual logarithms. So that means we're going to have to use either the product rule or the quotient rule or the power rule. So which one do you think we're going to have to use here? Quotient rule. So it'd be log to the base 10 of that x plus 4 will be in the numerator over x minus 4 in the denominator, and that's equal to 1. Okay, and then next we're going to write this, since we only got the logarithm on one side, we're going to write this in its equivalent exponential form. So log to the base 10 of x plus 4 divided by x minus 4 equaling to 1 means this. Here's my base, which is the 10. That 1 would be the exponent for the 10, so it'd be 10 to the first power. And then that's equal to that expression right there, x plus 4 divided by x minus 4. All right, and 10 to the first power would be 10. So here's what I'm going to do. Write this as 10 over 1, equaling to x plus 4 times x minus 4. And then from here, I'm just going to do cross multiplication here. That 10 will be multiplied by x minus 4. So I have 10 times the quantity x minus 4, equaling to 1 times the quantity x plus 4. And then distribute on both sides. So if I distribute the 10 over the x minus 4, what would I get? 10x minus 40. And of course, 1 times x plus 4 will be x plus 4. Let's see here. I need to get variables on one side and the constant term on the other side. Let me move that x over to where that 10x is by subtracting x. So 10x minus a 1x will be 9x. minus 40 is equal to 4. And then to get 9x by itself, we add 40 to both sides. Yeah. So 9x would be equal to 44. Then divide by 9, and I will leave this as an improper fraction. X equals to 44 over 9. And in this case, I will go no further than that. Okay. So x equals 44/9 for this one. All right. Are there any questions about problem number 3? Okay, problem number 4 deals with limits. And here you were given a graph. And we want to use that graph to find their limits here. And this is parts A, B, C, and D. And I understand that the graph here is not that great here. So in part A of number 4, we want to find the limit as x approaches 1 from the left of the function f of x. So here's for A. The limit as x approaches 1 from the left of the function f of x. So if I zoom in a bit, if you look at the graph, as we approach 1, here's 1, and from the left of 1, we're coming in from the left of 1, the f of x value is getting closer and closer to what value? 2. So the limit as x approaches -1 1 from the left would be 2. Okay, that's part A. And then part B asks for the limit as x approaches 1 from the right of f of x. So if we look at the right side of 1, which is here, what value for f of x will it get closer and closer to? 2. So the limit as x approaches 1 from the right of f of x will be 2. Then part C is the limit as x approaches just 1 of f of x. What do you think that would be equal to? Same thing. Because notice that the limit as x approaches 1 from the left is 2, and so is the limit as x approaches 1 from the right of 2. Both the left-hand and the right-hand limits must be approaching the same value for it to be that value. So the limit as x approaches 1 of f of x is 2. If the limit, let's say the limit was of x approaches 1, approaches this number, and then to the right it approaches another number, then at 1, its limit would not exist. Now part D is f of 1. They're just asking what the value of that function is when x is equal to 1, which is, of course, 2. Okay. Any questions about problem number 4? Okay. All right, problem number 5 looks like this. Here we want to find the given limit. That's the limit as x approaches -5 of x squared minus 4 divided by 5 minus x. Okay. I'll put 5 down here. That's the limit as x approaches -5 of x squared minus 4 divided by 5 minus x. All right, with this problem, will we ever get a 0 in the denominator if we did direct substitution? No, it wouldn't. So we can use direct substitution with this one. So I can just directly substitute each x with the -5. So here I'm going to have -5 and that's squared, minus 4, divided by 5 minus the x, which is negative 5. And then let's just simplify the numerator and the denominator. Square negative 5, you're going to get 25 minus 4, negative 5, well, 5 minus a negative 5 is 10. And 25 minus 4 would be 21 over 10. And that would be as far as I would go with that problem. So the limit as x approaches negative 5 of x squared minus 4 divided by 5 minus x will be 10. All right, any questions about problem number 5? Okay, problem number 6. Someone had this. Okay. Number 6 deals with, and I'm only going to focus on just the one in part A only, just that. I'll just say part A only. And here we got f of x is equal to 2x squared minus 5x minus 3 divided by x squared plus x minus 12. And we want the limit as x approaches 3 of f of x. Okay. Now, if I did direct substitution here, would I get a 0 in the denominator?
No.
Take a look. If you square the 3, that's going to be 9.
Yeah, 12 minus 12 is
Plus 12, 3 is 12, 12 minus 12 will give you 0. So I would get a 0 in the denominator. So pretty much I cannot use direct substitution. What I'm going to have to do here is see if I can factor the numerator and the denominator and divide out any common factors here. And then use direct substitution. So I'm going to bring over the limit as x approaches 3. Let's see if we can factor this numerator. Let's see, 2x squared breaks up as 2x and x. And I need factors of a negative 3. That's going to give me negative 5x. Well, let's do this. If I put that minus 3 next to that x and the plus 1 next to the 2x, 1x and a minus 6x will give me the minus 5x. And then for the 3, x squared plus x minus 12, I know I got an x here and an x here. I need factors of 12 that would give me a 1x. Okay. We can use that as well. And now you can see here we can divide out x minus 3. So now we got the limit as x approaches 3 of 2x plus 1 divided by x plus 4. And from here we can do direct substitution since I won't get a 0 in the denominator. So this 2 times 3 plus 1 over 3 plus 4. What's 2 times 3 plus 1? 7. Over 3 plus 4, that's 7. 7 divided by 7 is 1. So the limit as x approaches 3 of that function f of x will be 1. Okay. Now I'm just dealing with part A only on this in this handout. So any questions on number 6A? All right, now number 7. Number 7, I'm going to deal with just part C only. So here's number 7. Find each function value and, well, just find the limit as x approaches infinity of f of x. And here f of x is equal to 4x plus 4 divided by 7x minus 7. Let's see, f of x is equal to 4x to the 4x plus 4 divided by 7x minus 7. And I want the limit as x approaches infinity of f of x. So that means here I just want the limit as x approaches infinity of 4x plus 4 divided by 7x minus 7. What I can do here is divide the numerator and the denominator by the highest exponent in that denominator. And the highest exponent in the denominator will be x to the 1 power. So bring this limit notation over, because we haven't taken the limit yet. And then 4x will be divided by x. Then this 4 will be divided by x. The denominator, 7x, will be divided by x, minus, and then 7 will be divided by x. Now here we got the limit as x approaches infinity of, if I take 4x, divide that by x, that would be 4. And then plus 4 over x divided by 7x divided by x will be 7, and then minus 7 over x. Now, we know the limit of a constant will be that constant. But if we take the limit as x approaches infinity, this 4 over x goes to 0, and also 7 over x as we let the limit as x goes to infinity. That's going to go to 0 as well. So all you'll be left with is 4 7s. Now I know on here they say round to the nearest thousand as needed, but you can leave it as 4 7s if you like to, or if you choose, just do 4 divided by, yes.
On an exam, if you realize that it's gonna end up just being the two constants on the variable,
Yeah.
the two, do you have to do all those other steps, or can you just?
Just say 4 7s because the numerator and the denominator are the same. The same exponent on the x. Okay. Any other questions? Okay, that's problem number 7. All right, number 8 is this. Determine whether the function f of x is continuous. And in this case, we got f of x equals to the square root of x minus 5. Now, here we got a square root. Okay. We know that for a radical, for a square root, that's only true if what's underneath that radical is a positive number or 0. So that means I need to take that expression x minus 5 underneath the radical and set it to be greater than or equal to 0. And get x by itself. So if I add 5 to both sides, that means x is greater than or equal to 5. Meaning any x value greater than or equal to 5 will satisfy that radical function. And they want the interval notation for this. So that means here, if this helps, you can draw a number line. Put 5 on that number line. And of course, we're going to use either a bracket or parentheses. Since it's greater than or equal to, that means, and 5 is included, we use a bracket. Any x value greater than 5 would satisfy that radical function. So that means the interval would be from 5 on to infinity. From 5 on to infinity would be the values of x that would make that radical function continuous. Okay, questions on number 8? Okay, number 9. All right, in number 9, we're finding derivatives here. So here we got y equals to x to the negative third power, and we want to find out what dy dx is going to be. So dy dx, if we were to use what they call the power rule, what do you think that derivative is going to be?
Negative 3x. To the negative 2?
Negative 4.
Negative 4. Bring the power down, that's in negative 3, copy the x over, and it's going to be to the 1 less power, so you have to think of negative 3 minus 1, which will be negative 4. So dy dx will be just negative 3 x to the negative 4 power, and you can leave it like this. Okay. Questions on problem number 9? Okay. Let me go down here to problem number 10. In problem number 10, they want you to find f of t, f prime of t, if f of t is equal to 3t squared minus 2t plus 9. So for f prime of t, we're looking for the first derivative here. So what would be f prime of t?
16 minus 2.
Yep, 6t minus 2. Bring the 2 down, multiply by 3, you'll get the 6. Copy the t over to the 1 less power, so it'll be t to the first, or t. The derivative of minus 2t would just be that constant minus 2. The derivative of the constant plus 9 would be 0. So f prime of t ends up being 6t minus 2. All right, questions on number 10. Okay, now problem number 11, we got y equal f of x, which is equal to x cubed minus 4x plus 6, and they asked you to find dy and y and delta y, given that x is equal to 3 and delta x is equal to 0.1. All right, so let me go and write down the function. I'll just say f of x equaling to x cubed minus 4x plus 6. And we're told that x is equal to 3, delta x is equal to 0.1, and they want the dy and delta y. All right, let's first get the derivative of this, or f prime of x. So what would f prime of x be here? 3x squared minus 4. Bring the power down, copy the x over to the 1 less power, and then minus 4, and the derivative of 6 is 0 since it's a constant. All right, and we also should know this, that dy is equal to f prime of x dx. That's when we were talking about differentials here, back in section 2.6. So I'm going to bring down this dy, and that's equal to f prime of x. We found that out to be 3x squared minus 4 dx. Now from here we can find out what dy is, because we have our x equaling to 3. So all we do there is just substitute that x here with the 3. And also, delta x is 0.1. This is the same as saying dx. So dx is equal to 0.1. So we can substitute the dx with that 0.1. So now we got dy is equal to 3 times x, which is 3, and that's squared, minus 4, times dx, that's going to be 0.1. And I'm going to go ahead and do all of this in the calculator. I'm going to do 3 times 3 squared minus 4. Well, let me just do this part right here. That's 23. And 23 times 0.1 is 2.3. So dy is the 2.3. And they also want delta y. Well, this goes back to the original definition of what a derivative is. And of course, that's a change in y divided by the change in x. The change in y, or delta y, is this: f of x plus delta x minus f of x. That's the new, if you recall, we did the limit as x as delta x approaches 0 of f of x plus delta x minus f of x, all divided by delta x. That part there is the numerator, which is your change in y. All right, so now let's find out what delta y is. We have f of x, which is 3, plus delta x, that's 0.1, minus f of x, which is 3. And I'm going to do 3 plus 1, or 3.1, minus f of 3. Now here we're going to have to find out what f of 3.1 is and what f of 3 is. Using our original function f of x equal to x cubed minus 4x plus 6. And I'm going to have to do this in the calculator, so this will be, I'm going to put the 3.1 in parentheses. Since it's cube, I'm going to do the hash key and then cube. And then minus 4 times the 3.1 plus 6. So f of 3.1 gave me 23.391. And then for the f of 3, well, just substitute the x with 3 in the original function, so that'd be 3 cubed minus 4 times 3 plus 6. And for that, I get 21. So f of 3.1 was 23.391 minus f of 3, that's 21. And if you subtract 21 from 23.391, you'll get 2.391. That is what delta y is. So here, delta y is 2.391, and dy is 2.3. Okay. Are there any questions about problem number 11? All right, number 12. Find the average cost function if cost and revenue are given by C of x is equal to 149 plus 8.5x and R of x is equal to 2 minus 0.8x squared. All right, so you're given the cost function and the revenue function, but they just want the average cost function. So that means you just want to focus on just the cost function C of x. So So here c of x is going to be 149 plus 8.5x. So now to find the average cost function, that's c bar of x. That's going to be our cost function divided by x. So here I'm going to have 149 plus 8.5 x divided by x. So each term in the numerator will be divided by that one term of x. So it'll be 149 divided by x plus 8.5 x divided by x. So I got 149x plus, and the x is divided out in the 8.5x divided by x. So you're left with just 8.5. This represents your average cost function, 149 over x plus 8.5. Okay. Any questions on number 12? All right, number 13. And I'm just going to deal with just 13A only. So 13A is just the only one I'm going to deal with. Recently, a certain bank offered a 5-year CD that earns 2.17% compounded continuously. And I want to use this information to answer part A only. If $20,000 is invested in this CD, bless you, how much will it be worth in 5 years? And we're going to round to the nearest cent, or 2 decimal places. All right, so now a 5-year CD, so that means our time is going to be 5 years, and it earns an interest rate of 2.17%. Now what's 2.17% as a decimal? Correct. And it's compounded continuously. So our formula that we're going to be using is a little bit different than the one that we use in problem number 2, I believe. Yes. A is equal to P times e to the RT. And we're told that $20,000 is invested in this CD, so that means our principal is $20,000. How much will it be worth in 5 years? So all we have to do there is just do some substitution here to find out what A is. So A is going to be equal to P, which is 20,000, times E to the R, that's going to be 0.0217, times T, which is 5. So now we're going to do 20,000, type that in, for the E, second, LN for the E, and then we can type in 0.0217 times 5, and hit enter. And to the nearest cent, or to 2 decimal places, what would this amount be? $22,292.10. Right, $22,292.10. That represents how much the CD would be worth after 5 years if $20,000 was invested. Okay. Questions on problem number 13? All right, problem number 14. Here we got f of x equals negative 11 ln of x plus 4x squared minus 12. So now we're looking at derivatives of exponential and logarithmic functions here. and they want the first derivative, f prime of x. All right, so here for the first term, we got negative 11. What's the derivative of ln of x? 1 over x. Plus the derivative of 4x squared would be 8x. And the derivative of minus 12, 0. Okay. So if I simplify this a bit, I'll put the negative 11 on top and the x will be in the denominator, plus 8x. So f prime of x will be negative 11 over x plus 8x. All right. Any questions about problem 14? Okay, problem 15. Here we're going to use the product rule to find this derivative. So in this case here we've got y equal 3x squared plus 2 times the quantity 5x minus 3. Okay, and they want y prime. All right, since we're using the product rule to find this derivative, the product rule says this: you must do the first times the derivative of the second plus the second times the derivative of the first. I'll even write it like this: first times the derivative of the second plus the second times the derivative of the first. So this is going to be the first, and that's the second. Then y prime would be this. Copy the first expression. That's the 3x plus 2. Take the derivative of the second expression. What's the derivative of 5x minus 3? 5. And then plus copy the second, which is your 5x minus 3, times the derivative of the first. What's the derivative of 3x squared plus 2? 6x. So now we got y prime equaling 2, and here's where the algebra comes in. We distribute the 5 over the 3x squared plus 2 to get 18x squared plus 10. And then if I distribute the 6x over the 5x minus 3, I would get 30x squared minus 18x. And we can go ahead and combine some like terms here. 15x squared and 30x squared will give us what? 45x squared. And then the rest I just have to bring down as minus 18x plus 10 using descending powers. Okay. Are there any questions about problem number 15? So this is what y prime is using the product rule. All right, number 16. Here we got f of x is equal to e to the x divided by 9x squared plus 5. So that's problem number 16. Now, what rule do you think we're going to need to take its derivative? The quotient rule. Because notice I have a numerator and a denominator, so I need to use the quotient rule to take its derivative. So if I do f prime of x, okay, and this is going to be the high and the low. So if the high is e to the x, and the low is 9x squared plus 5. What's the derivative of the high? Derivative of e to the x. E to the x. And the derivative of the low, that's your 9x squared plus 5. What's that derivative going to be? 18x. Okay, so here's what we got. The low times the derivative of the high. So the low is at 9x squared plus 5 times the derivative of the high, that's e to the x, and then minus the high times the derivative of the low. The high is the e to the x times the derivative of the low, that's your 18x. All that will be divided by the square of the low. And that's 9x squared plus 5 quantity square. Okay, so it's low d high minus high d low, all divided by the square of the low. Now let's simplify that numerator a bit. What can I factor out in these two terms here? E to the x. So if I take out the e to the x, this is what I'll have. What's left would be that 9x squared plus 5. Then minus, if I take out the e to the x there, I'll have 18x left. All that's divided by the square of 9x squared plus 5. And the best I can do here is just put these terms in descending power. So f prime of x ends up being e to the x times the quantity 9x squared, then minus 18x plus 5 divided by the square of 9x squared plus 5. Not go no further than that. Okay. Questions about problem number 16? All right, number 17. Let's say we got f of x is equal to 8 times the square root of 7x squared plus 5. And we're going to find f prime of x here. And I believe with this one we have to use the chain rule. And there are a couple of ways you can do this, but let's go the obvious way here. I'm going to write this as f of x equals to 8 times the square root of 7x squared plus 5. If I wrote that in exponential form, it would be to what power? 1/2. And then use that power rule and then the chain rule. Okay? So to find f prime of x is this. I'm going to bring down the 8, copy that, bring down that exponent of 1/2, copy over the 7x squared plus 5, and that's going to be to the 1 less power. So 1/2 minus 1 would be, what's 1/2 minus 1? Negative 1/2. And then I got to take the derivative of this inside function. The derivative of 7x squared plus 5 would be 14x. Okay. So now if I simplify this a bit, let's see here. Half of 8 would give me 4. 4 times 14x would give me, should give you 56x. Then that's multiplied by 7x squared plus 5 to the negative 1/2. And I'm going to put this in the denominator with a positive exponent, so it'll be 56 over 7x squared plus 5 to the 1/2. And then write that back in radical form as 56 over the square root of 7x squared plus 5. Now in the exam, if you left it like this, or if you went ahead and wrote it like this, you'll get full credit for it. 56x. Okay. Any other questions about problem number 17? So this one is where we talked about the chain rule. Because you're taking the derivative of a composite function. So that's 17. Okay, number 18 is implicit differentiation. And they tell you to use implicit differentiation to find y prime. And then evaluate y prime for x squared y minus 3x cubed plus 8 equal to 0 at the point 24. So let's see what we got here. We got the equation x squared y minus 3x cubed plus 8 equals 0. And the point that they're dealing with is 2, 4. The ordered pair 2, 4. All right, so let's take a look at what we can do here using implicit differentiation. And when you do implicit differentiation, anytime you take the derivative of y, you have to include dy dx in that problem. So like in the x squared y, there's a rule that we're going to need to use here to do x squared times y, and that is would it be the product rule? Because you got x squared times y. So the first thing I need to do here is just copy the first term times the derivative of y. The derivative of y would be what? 1. But since I'm taking the derivative of y, I must include this notation, dy dx. Minus, and the reason why I'm doing that because I'm assuming that y is some function of x. So I have to include dy dx. And then minus the derivative of 3x cubed. That's going to be what?
9x squared.
9x squared. Yeah, minus 9x, and then you square it.
Will we not finish the power or the product?
Oh, that's right. Okay, let me finish this before we move on here. Because I only took the first times the derivative of the second, but I forgot to put the second, which is the y, times the derivative of the first. What's the derivative of x squared? 2x. Now we can do the derivative of minus 3x cubed. That would be minus 9x squared. Derivative of 8 is 0. That's equal to 0. Okay, let me clean this up just a little bit. Got x squared dy dx. Plus, I'm going to put the 2x in front of the y. Then minus 9x squared is equal to 0. Now, let's get dy dx by itself. So I have x squared dy dx. And if I move that minus 9x squared over to where the 0 is, that's going to be 9x squared. And then if I move that 2xy over to the other side, it'll be minus 2xy. So I got 9x squared minus 2xy, and that's equal to x squared dy dx. Then I can divide both sides by x squared to get dy dx by itself. So that means dy dx is equal to 9x squared minus 2xy, whole thing's divided by x squared. So that's what dy dx is, or as they say, y prime. But y prime and dy dx means the same thing. Me personally, I just like to use dy dx. Just want to let you know. Now, at the point 2, 4. So I'm going to say here at the point 2, 4. Here x is 2 and y is 4. We just substitute the x with the 2 and the y with 4. So I got 9 times x, which is 2, that's 2 squared, minus 2 times x, which is 2, y is 4. All that's divided by x squared, and x is 4. X is 2, and we're squaring it. So if I do 2 squared, that's going to be 4 times the 9 would be 36. minus 2 times 2, that's 4, times the 4 I have here, that's 16, over 2 squared is 4. Then 36 minus 16 will be 20. 20 divided by 4 gives me 5. So at the 0.24, y prime or dy dx would be 5. And that actually represents the slope of the line. That's slope of the tangent line that's going through the 0.24. Questions on number 18. All right, number 19. Is a related rate problem. An oil tanker aground on a reef is forming a circular oil slick about 0.2 foot thick. To estimate the rate dV/dt in cubic feet per minute at which the oil is leaking from the tanker, it was found that the radius of the slick was increasing at 0.33 foot per minute, or dr/dt is equal to 0.33. When the radius, capital R, was 500 feet. Find dV/dt. And you're told to use pi equaling to approximately equaling to 3.14. And you're also given some formulas here in this picture, where you got A is equal to pi r squared, and you got V is equal to 0.2 times A, which is your area. Okay, so let me go ahead and write those down. Capital A, that's the area of the circle, pi times the radius square. And your V is 0.2 times whatever that area is. Well, let's substitute the A with that formula pi r squared. Let's do that. So that means our volume would be 0.2 times A, that'll be pi times capital R squared. So that's the formula for the volume. And I'm also going to identify some other things that's given to me. Let's see here. The radius was increasing at 0.33 feet per minute. That was dr/dt. And that's when the radius was 500 feet. So capital R is 500. Okay. And I think I have what I have here. Okay. So now with this formula, we're going to take the derivative of each variable with respect to time. So that means here, the derivative of V will be dV/dt. And 0.02 and pi are constants. I can write those down. The derivative of r squared would be 2r. And then I have to include dr/dt. And if I simplify this a bit, let's see here. 0.2 times 2 would be 0.4, I believe. So it'd be 0.4 times pi times r dr/dt. Yeah. Just want to make sure I had this right. Now we're finding dV/dt. So dV/dt is this, 0.4. And I'm going to replace the pi with 3.14. The radius, of course, is 500. And of course, 500 feet times dr/dt, that's going to be 0.33. So in this case, if I just multiply those numbers, 0.4 times 3.14 times 500 times 0.33, And if I was to round this up to the nearest whole number, what would that value be?
207.
207. So this is going to be 207, and this will be in cubic feet since the volume is in cubic feet, cubic units. And with respect to time, time is in minutes, so it'll be per minute. So dV/dt would be equal to approximately 207 cubic feet per minute. Okay.
I just got a question.
Yes.
If you're taking the derivative of that v equals 0.2 pi r squared, and you said the 0.2 pi is constant.
Yeah.
How is that involved in that if it's a constant? Wouldn't that be 0 if you're taking the derivative?
I mean, you could use the product rule, but really, if you did the product rule, it would be 0. But pretty much you can just bring that constant on down and just take the derivative of r squared.
Oh,
Same like if I took the derivative of 6x, it'd just be the constant 6. And then the derivative of x will be 1. Same thing. Any other questions? Okay, problem number 20 is finding the relative rate of change. Okay, so here we got 11 plus f of x equals to 11 plus 5 ln of x. And here I want the relative rate of change. So if I want the relative rate of change, that means I need to do f prime of x divided by f of x. F prime of x divided by f of x. And from here I need to know what f prime of x is going to be. 5 over x, because the derivative of 11 is 0. Bring over the 5, the derivative of ln of x will be 1 over x. So if I simplify that, that would be 5 divided by x. So f prime of x is 5 over x. And then that's going to be divided by f of x, which is going to be 11 plus 5 ln of x. Now I need to simplify this a bit. What can I multiply the numerator and the denominator by? By x. That's what I'll do here. And in this case here, when I do that, in the numerator, these x's divide out. I'll be left with the 5 divided by, and I'll put the x in front, and that'll be multiplied by, in parentheses, 11 plus 5 ln of x. And I will go no further than that. Okay. Anybody have any questions about problem number 20? Okay. I'll tell you what, why don't I stop right here? The remaining 10 problems that deals with material out of chapter 4 and chapter 5, we'll talk about that on Wednesday.